we're going to be using substitution and elimination to solve systems of equations. Substitution and elimination are two methods you could use to solve systems of equations, whichever you prefer. The first one we're going to be learning how to do is substitution. The steps are to solve one of the equations. You can choose whichever equation you want, and then you use the other equation and use as the variable. You can choose which one as well. Plug this back into the other equation, which is why it's called substituting, for the chosen variable and solve for the other, and then back solve for the first variable. So I already pre-wrote everything, our first example, but I'm going to be going over it on how I got to my x and y. So first, I used this equation because for our first equation, y is already by itself. So, and because this equation does not have y by itself, we can just plug in this into y, which is what I did here. Next, you would just transpose your -3 to whatever's in the parentheses to get rid of the parentheses. And then you would end up with these two numbers. And then next you would have to figure out your similar terms, which in this case would be -2x and -18x, and you would combine these two and you end up getting -20x, and then you would bring -7 and 33 down as well. And now, because you want to get x by itself, you would have to subtract 33 to get rid of the 33, and subtract 33 also on the other side, and you would end up with a -40. And now to get x by itself, you would have to divide -20, so it gets rid of the -20, and you also do on the other side, and you would get x equals to 2. Now to get your y variable, it's a lot more simpler. You can choose whichever of these two equations you want. Ultimately, you should go for the simpler one because it's faster. So in this case, between our two equations, y equals 6x take away 11 is the simplest. So you'll plug our x term into x here in our 6x, which is seen over here. And you would just combine everything. So 6 times 2 equals 12. Subtract 11 from 12 and you get y equals to 1. But you can't just leave it like this, so you have to write it as coordinate points, which would look like this. So this would be your final answer. X would always go first, and then your y is your second number of your coordinate points. So this is our second example. Ivy. Oopsie.
You can continue.
Wait, I made a mistake. Oopsie. All right. So this is our second example. Oh my god. I keep. Okay. So this is our second example. Again, we have two equations. This one on the right is our simpler equation. So you will plug So we would use our more difficult equation, I guess you can say, and you would plug in your negative 5x and negative 17 into the y in negative 3y, and that would give you, and that will give you this entire equation on the left. And you would do what you, and then you would have to use PEMDAS, if you remember what PEMDAS means. You know, get rid of the parentheses first. So you have to multiply your negative 3 to whatever is in the parentheses first to get your 15x and 51. And then you combine your like terms, which is negative 3x and 15x, and you would end up with 12x, and you bring everything else down, and then to get 12x by itself, you would have to subtract 51 on both sides, so you also get rid of the 51, and you get, and on the other side of your equal sign, you would get negative 48. And to officially get rid of your 12, so you have just x alone, you have to divide your 12 on both sides. So you get negative 4 as your x value. And now you have to get your y value, which you have to plug in your negative 4 into whichever equation you want. I went with the simpler one. You could also use this one if you want, but simpler, easier. So you would place your negative 4 here, and you would combine everything. So negative 5 times negative 4 equals 20, take away 17, and you get your y value of 3. But again, you can't just leave it like that. You have to put it in coordinate point form, which is that x value is always first and your y value is always your second. And now, your turn.
Are there 6 equations or like 3?
3.
Oh, okay, I thought it's 6.
Caitlin,
Right.
can you make it possible for me to annotate, or is that like...
You can't annotate.
No, I don't think so. I think it's only like phones and yeah.
I'll give you hosting privileges after.
Okay. Caitlin, he needs help with the first one.
I know. Okay. So for the first one, oops. Okay. So for the first one, you would, because like y isn't alone or x isn't alone, you would have to choose one of these. You have to choose one of the equations and make it so y is by itself for one of the equations. So depending on which one you want, I'm just going to choose this first one because y is positive. You would have to take this negative 4x and transpose it to the other side of the equal sign. Again, you have to also, because you are transposing your negative 4x to the other side, it has to be turned into a positive 4. So essentially, it will look like y equals 6 plus 4x. You don't have to do anything to this equation because we have y alone. So you would take negative 5x minus, and then put these two numbers in parentheses in your equation. Can you solve that? Remember that in front of this parenthesis, because there is a negative sign, that this is a negative 1, just invisible. So could you try solving that? Does that help?
Yeah, okay, I try.
Okay.
So the answer is x equals negative 3.
Okay, and your y value?
I didn't get to that part.
Okay, get your y value. Okay, so your y value so how you would get your y value is that you said x equal to -3, which is correct. So you would take one of these equations. You can even take y equals to 6 plus 4x because it's a simplified version of this equation. So you would take one of the equations and solve for x because I previously solved this and simplified it so y is alone. I can just use this equation. So y would equal to 6 plus 4 parentheses -3. And then you would combine all of these, which would equal to your y, 4 times -3 plus 6, it would equal to -6. And again, you can't keep it just like that, you have to put it in coordinate form. So this would be your entire answer. Did that make sense?
Yeah.
All right, try solving for the second one.
Caitlin?
Oh, sorry. Okay, so for number two, you would, as you can see, no y value or x value are alone. So you would turn one of them. So the y value is alone. So since the first one, this one, doesn't have a number in front of it, it's more like an invisible one. We're gonna turn this one, so y is alone, and we would do that by transposing your negative 5x to the other side. So it would be so it would turn into a positive 5x, which would look like this. Oops. Yeah, and then you would use this equation, and so you would plug in this part into this equation because negative 8x has a y. When I transpose, you don't understand? Like,
Yeah, like when you changed it. So I don't get that.
so you're transposing so you get y alone or x alone, depending on which value you want to get alone. And you would transpose it by like taking, so if it's like a positive or a negative, you would take it to the other side and change it to the opposite of the sign. So if it's a negative 5, you will transpose it so it would be a positive 5 because it would be over the equal sign. If it's a positive 5x, it would be a negative 5x. Does that make sense?
Oh,
No.
got it.
All right. So now we're going to put negative 3 plus 5 into here because there's a y value, and you can substitute it that way. Now try solving that. Remember to multiply negative 8 to your negative 3 and your 5x. And remember, use PEMDAS. Try solving that. Shall we shall we do it together? Yes, I will. So when you multiply 8 with -3, you will get a positive 24. And then you multiply -8 with 5x, and you get a negative 40x equals 24, and bring down the 3x. And now we combine like terms. In this case, it's the negative 40x and positive 3x. And you'll get 20, not 20, negative 37x. And now we bring everything down. And now we would minus 24 on both sides. And that's 24. And then you get 37x equals to 0. Divide to get your x alone. And x would equal to 0. And now to get your y value, again, we're just going to use the one that I made from this. So y equals to -3 plus, I need to erase. Okay. -3 plus 5, but instead of writing x, we will write 0. 5 times 0 will equal 0 plus -3. You will get -3 as your y. And again, write it in coordinate points. So that would be your answer for this question. Make sense?
Yeah, I am struggling here.
It's all right. We can go over it later in the end. Try the last one. All right. So in our, I forgot to go annotate. Okay. So for this one, our first equation here, x is already alone. So instead of transposing y, our y value, or 3y, like we have done for these two, we are going to transpose our y over to this side instead of the x, because x is, well, it's simple. It's 1x pretty much. So we will transpose our 3y over to the side, which will turn into x equals to 1. And because this is a positive, it would be a negative on this side, 3y. And now because x equals to 1 minus 3y, we will replace the x here with the negative 1, 3y instead of the y value that we have done for these two. Try solving this. X does not equal 1. Try again. Or do you just want me to go it over?
Let me try again.
All right. That's correct. But we're not solving for x, it should be y. So you're solving for x.
Oh yeah, I just kind of
Yeah.
like hesitated.
All right, that's all right. Now solve for x. All right. So you already solved for y, which was -2. To solve for your x value, we're gonna choose one of these 3 equations, depending on which one you want. I'm just gonna choose.
Wait, does any one of them gonna work?
Yeah, any of them can work.
Oh, okay, any. Alright.
Do you want to solve it now, or should I just go it over?
You should go over.
All right, so I'm just gonna choose this one because x is already alone. So, so instead of writing y, we would write our -2 in parentheses. And now we will combine everything. So -3 times -2 equals to -6 plus 1. Wait, no, I made a mistake. -3 times -2 equals to a +6 plus 1. X equals to 7. And again, can't write it as just x equals or y equals. You have to write in coordinate points. So that would be our answer. Make sense? Make sense?
Yeah.
All right. And now I'm going to let Ivy do elimination.
Hi, do I share my screen?
Yeah, I gave you hosting privileges.
All right, okay. Okay. Can you guys see my screen?
Ma'am.
Yeah, we could.
Okay, well, we're gonna do elimination. So what we want to do is multiply the equation by like a number so they'll both equal the same number. So we're here, same leading coefficient. And then you have to subtract the equation from the second equation from the first. So you want to isolate the variable. So then you would get the variable by itself. So then you would do what Caitlin just did. You would just substitute it into either equation to solve for x, so you can have both to make a coordinate. So let's practice on this. Okay. Let's do this side first. Well, actually, never mind. What am I saying? Let me get annotations on. Okay, so let's rewrite this, okay? So we'll keep this 4x plus 8y equals 20. And then you wanna just copy down, I'm sorry for the handwriting. You just wanna copy down the same equation from the right-hand side underneath the first equation, so it looks a little bit neater, so you can see what numbers you're actually dealing with and where it is. So what you first want to do is find, does any of the variables coefficient have the same number? And over here you can see that x, they both have 4, and I don't have to like multiply it by a negative so they can cancel out, because what you want to do is cancel one of the variables out. So 4x minus 4x gives you 0. So you have 0. And then you just combine over here. So 8y plus 2y, positive 10y, positive 20 minus 30, negative 10. Okay. And then you want to solve for y. So you do like every other equation. You just divide both sides by the positive 10, which gives you y equals to negative 1. And then you want to solve for x. So take your y equals to negative 1 and plug it into either equation you want. Just for now, I'll do into the first equation. So it'll be 4x plus 8. But instead of y, we're going to put parentheses negative 1 because that's what y equals to 20. And then we'll just solve it like a regular equation. So we have 4x. 8 times negative 1 gives you negative 8. So you put that there, equals to 20. And then we just want to isolate 4x by itself, right? So in order to get rid of the negative 8, you would add 8 on both sides. So it'll give you equal to 28. And finally, all you have to do is divide by 4, the coefficient of x, because you want x to be by itself. So x will equal 7. And as Caitlin said before, you want to write it in coordinate form, unless they ask you just for that, find x, find y. But since we're not doing that right now, you want to write in coordinate form so you know you have both. So x comes first, and then it's the y value. So equals to 7 comma negative 1. Anything you don't understand or like to clarify?
No, I got it. Wait, hold on. So did you just basically subtract with the first equation with the second equation, right?
Yeah, but you want to make sure you're allowed to. So here, as I said, 4x minus 4x. Both have the same coefficient. Coefficient is the leading number in front of the variable. So you want to make sure it's the same variable, same coefficient, and you want to subtract it. But let's say it wasn't a negative. Let's say it was 4x and positive 4x. What you would have to do is put parentheses around everything and then multiply the whole thing by negative 1 in order to make that a negative 4x, so you can cancel them out and create a 0. But if you don't want to do that, the harder, well, not harder, but the more like annoying way is to like cancel out the y's, which would make you multiply the whole second equation by 4. So this would be negative 4, so this will give you negative 8, and then you'll cancel out the y. Is that confusing? Did I like say too much?
Yeah, it's kind of confusing.
Okay, let's see, let's do the next question together and maybe like. Okay, let's try this one again. Okay, so we have two equations just like before, but we want to do is stack them together so it's easier to look at. What I usually like to do is if it's like if they already give you like a negative, like over here is already a negative, and like they're both 6x, right? So you know you can cancel them out to create a 0. So I just put the negative on the bottom because that's how you usually subtract, you know? And then you put the first equation on the bottom. Doesn't really matter. It's just easier to look at this way. So 6x minus 6x give you 0. 4y plus 5y equals to positive 9y. Negative 10 plus 1 gives you negative 9. And then we just want to make sure we isolate y by itself. So you divide by 9 on both sides, positive 9, because that's the leading coefficient. Coefficient is the number before the variable, like right next to it, like when they're attached. So negative 9 divided by positive 9 gives you negative 1. But as we said before, it doesn't say find y, find x specifically, so we want to make sure we have both as a coordinate. So let's go find x. So what we do is take our y equals to negative 1, and we plug into either equation. For this one, I'm just going to use the second equation because I prefer dealing with positives. It's easier for me. So I do positive 6x. I just rewrite the equation, but I'll replace y with negative 1 because in this example, that's what y will equal to. So you just solve it normally. So 6x minus 4, because positive 4 times negative 1 gives you negative 4. Bring down the negative 10. And then you have 6x. You want to make sure you isolate the 6x by itself. So you would add 4 on both sides in order to get rid of the negative 4. So negative 10 plus positive 4 gives you negative 6. And then we want to isolate x. So you would divide 6 on both sides because that's the leading coefficient of x. So you have x equals negative 1. So these are your two answers. In order to combine them, you do negative 1, comma, negative 1. Anything you're confused about?
No, I got it this time.
Okay. Try these examples on your own. There's 3 questions because in each question you need to have 2 equations.
Ivy, look in chat.
Okay, that's not the answer for number 1. Do you want to do it together or do you want to try it again?
Let me see, I could do it again. I need help with it.
Okay, let's do number 1 together. So, alright, so as you can see, there's no common coefficient between the variables, so we want to make it. For this time, okay, I cancel out x, so what you would do is multiply, that's a parentheses, by the way. So I did it by 4. So using that, I would get 4x plus 9y equals 9. And then, so distribute the 4, I would get positive 4x, negative 12y, and then equals to negative 24. Now, negative 4x plus positive 4x, cancel it out because your x have the same number coefficient, just opposite symbols, signs, so that's 0. You can put the 0 here if you want. And then what's positive 9y minus 12y? What's negative 12y plus 9y?
Negative 3.
Negative 3 what? You're missing something.
Oh, y.
What's positive 9 minus 24? Positive 9 minus 24. Negative 24.
Negative. Okay.
Yeah, what's up?
Yeah. Okay.
Ready?
Negative 33.
This is positive 9. So positive 9 minus 24.
Negative 15.
Yep. And then how do you get rid of the, how do you isolate y?
Divide by 3.
No, try again. You're forgetting something.
The 0.
It's negative 3y. You cannot forget the negative sign. So what's
Okay.
negative 15 divided by negative 3?
5. Okay, positive 5.
Great, so now we have our y value, but we want to find the x value as well. So what we do is plug in this y value for any equation. I'm going to do it on the second equation, which is x minus 3y. But instead of y, I'm going to parentheses, plug in the 5, close parentheses, equals to negative 6. That doesn't change. So distribute the negative 3 to the 5, which would give you negative 15. equals to -6. Now, how would you isolate the x by itself? How would you get the x by itself?
You add 15.
Right, so what's -6 plus 15? You were right, you add 15 on both sides. So negative
Positive 9.
Yeah. So those are your two variables. What you would do is put them together since they don't specifically ask you to find x or find y. So it'll be 9 comma 5. That's your answer. Do you know what part you're having trouble with? Because like there must be like a common thing that's making you get these answers. So which part did you trip up on?
Well, I do understand of like adding and the dividing part, but the part where like you subtract, like in the first part,
That's the part you don't get?
yeah, the first part I don't get it.
All right. So, okay, let me just erase this so it's easier.
Like you put parentheses on there, like for
Right.
different cases, like.
Okay, I'll let you know why. So basically, we want to find out one variable. It doesn't matter whether it's the y or x, but for this example, I was doing x, right? So what you want to do is find like, like the opposite sign, but the same number in front of the variable. Like you can see this is negative 4x, right? So what we want to do for the second equation is to get positive 4x because negative 4 plus positive 4 gives you 0. And we want to cancel that out to get a 0. So we are only left with a y value because we want to isolate one of the variables just to get the other one. So that's why I put parentheses because you can't just multiply a positive 4 just to the x because it doesn't work that way, you know? You have to make sure everybody gets the same amount of multiplication to them or division to them. But in this case, we are doing multiplication. So that is why we're doing parentheses. So you just distribute like normally, which will give you positive 4x. And so 4 times negative 3y gives you negative 12y because 4 times negative 3 gives you negative 12. And you basically just bring down that y value. I mean, not y value, just the variable y. And 4 times negative 6 because you want to make sure you multiply to the right side as well, and you get negative 24. So that is why you multiply. Is it like still iffy? Because we can do another example together if you want.
Let's do another example.
All right. Okay, so here, right? What numbers do you see that can be like in common with each other? That is variable in front of the variable.
What do you mean by common?
Like, let's say 1 and 2, right? You just multiply the 1 by 2 to get both are 2. Or you see a 4 and a 2. Multiply the 2 to get a 4. So they're like common. They're like, yes.
Negative 3x and negative 9x.
Right. So what would you do to change the negative 3 into something with a 9?
You would multiply.
You can type in the chat. My chat is open next to the side so I can see whatever you type if that's easier for you.
Yeah, it's a little big background noise. It's a big one.
No problem. But yeah.
So you would multiply?
Multiply by what?
3.
Right, but think about it. If you multiply negative 3 times 3, what do you get?
You get negative 3, negative 9.
Right, but that's not what we want. We want to make sure one of them is negative 9 and the
So
other.
times by negative 3. I'm positive. I mean negative 3
Yeah.
times by.
So is it just to the x you want to do it here? You just want to do negative 3 here? You just want to do it to this one?
Also to the 7
Nice.
and the 16.
All right, so tell me, what is it equal to once you finish distributing it?
So if you distribute, you got positive 9x plus.
No, -3 to +7. Think about it. Because a negative times a positive gives you a,
A negative
so it's -21.
21. Yeah.
And then for the last part,
Positive 48.
correct. So now we have our two equations. So what we want to do is cancel out one of the variables. So we only get leftover one. So we just bring everything down. What's -9x plus positive 9x?
0.
Right, so let's do the next step. What's positive 5y minus 21y?
Negative 16.
That's it? Just -16?
Y.
Okay, and the final one. What's 16 plus -48?
Negative 32.
Right, so how do we isolate y? Like, how do we just get y here?
You did by 16.
Just 16? Nothing else?
Also by 32.
No, you're right, 16, but you're missing something. What are you missing?
Oh, the negative.
Right, don't forget about the negative. So after you divide, what do you get?
2.
Good. So y equals 2, and we want to find the x value. So what do I do now that I have a y? What should I do next?
So you pick one of the equation of the top and then you placed 2 on them.
Correct. Which equation do you want to do?
Well, can you pick any?
Yeah, you could pick either or. Doesn't matter which one.
Second one.
Second one. All right. So we have 9x. So we just rewrite the equation. 9x plus 5, but instead of y, we already have our y value. We both got 2, right? So instead of y, we parentheses, plug in the 2, close parentheses, and just finish up the equation. So what do I do next? How do I simplify this?
Oh, you multiply 5 times 2.
Right. So what does that give you?
Get 10.
Right. Okay, now that we have our new equation, how do we get the x on one side?
Or you subtract 10 and 16.
You subtract 10 by 16.
Yeah.
Right. So 16 minus 10. Easy, right? You got it? 6. Okay, how do we get x by itself?
You would divide.
By,
Negative 9.
right. So since this comes out to be a repeating decimal, you can just leave it as -69, or you can simplify it to -2/3. You know how to simplify it, right?
Yeah.
All right, so those are your two answers. So you have x equals to -2/3 comma 2 because that was our y value. So this would be your answer. Do you get a better hold on this? Do you want to try the third one yourself?
Yeah, I'll try. Let's see.
All right, I'll keep up here if you want to look at it. You're right. 2 does not go to 7. So remember, you don't have to just do the x value. You can do the y value as well. Either or, whichever one you decide to choose. It's just that recently, like, I've been doing y value, but you can start off with x value. So what you would want to do is find out a common term for the y value so you can cancel out the y value to 0. So you would just have the x value. Basically, just flip it. It doesn't matter. You don't have to just focus on the common term for the x. You can find a common term for the y. Did you get your answer or do you need help?
I didn't get my answer yet.
Okay, I'll wait.
Okay, so I got x equal 3, and I didn't solve for y.
Your x is wrong. The x, you want to give it another go?
No, I need a little help with that.
Alright, you know what? This time you're leading me through this. So how am I gonna solve this? What is my first step?
First step is parentheses.
For which equation?
For y, 7x, negative 7x plus y. Yeah.
Okay, what do I multiply it by?
By 3.
Just 3? Just 3.
Negative 3.
Are you telling me or are you asking me?
Hold on, it's positive 3.
No, it's negative 3.
Oh, wow.
I'll tell you why again. All right, so what we want to do is, remember, we want to cancel them out. You can't cancel them out if they're both positive or both negative, because then they would just like add to each other, right?
Yeah, but there's also negative 2x.
Okay, let's okay, here. Let's put negative 3 times negative 7 gives you positive 21x. Negative 3 times positive y gives you negative 3y. Negative 19 times negative 3 gives you positive 57, right?
Right.
Right. So when we bring down that second equation, you have something to cancel out, right? Negative 3y plus positive 3y. But if you kept it, if you just distributed a positive 3, you would get a positive 3y, positive 3y, negative 21x, negative 2x. What would you be able to cancel, right? You can't do anything, right? Let's see. I want to make sure in at least one of them, it could be either the y value or the x value, right? I want to make sure one of them has the same number, but they're different signs. So here in the orange, you can see they're both 3, right? But the thing is they have different signs. So that's what we want, because what's negative 3 plus 3?
0.
Right, exactly. That's what we want. We want at least one of them to be a 0. So then we can solve for x value, which would give
But in my equation, but how I did, I also got 0.
you also had 0.
Yeah.
Okay. All right, okay, tell me how you did. You said you distribute a positive 3, you said?
Actually, I didn't do it. I actually flipped the whole entire thing.
Huh?
Like, I put,
You flipped the entire thing? What do you mean you flipped the entire thing?
so basically I put y plus negative 7x.
Okay. Okay.
Yeah, right. Like,
Okay. And then what do I do?
times by 3.
Yeah, even if you times by 3, over here is positive 3y. You see? And this would still be negative 21x, just in a different order. You see, the thing is, it'd still be positive 3y, but we don't want that. We want a negative because already here, they already give us a positive. So we want the same number, just different sign for here.
Okay.
Do you get it? Or do you want me to try to clarify another way?
I got it.
Okay. And also before when you said in the third equation, 2 does not go to 7, you're right, but there is another way of solving it, which is to, if you like really, really wanted to solve x, you could do this. I'll do in red. You would just multiply this by 7, and then you would multiply this by 2.
So we multiply both.
No. If you really, really, really wanted to solve for y and you had to cancel out the x, right? But you said in the third equation, 2 does not go to 7. You're right. It's just that you could still solve for y, but you would have to go through like more numbers, you know? So a common factor of both of them would be 2 times 7, 7 times 2, both gives you 14. So you can just cancel out the 14x. But it'll make your numbers bigger because when you do like 7 times 19 and you don't have a calculator handy, that'd be like a pretty big number, right? So you want to make sure you do the smallest numbers you have. So right now we have a positive y and a negative 3y. I'm sorry, a positive y and a positive 3y. Sorry about that. So you would just want to make your positive y into a negative 3y, so you can just easily cancel the y's out and you get 0. So the only difference would be is you would solve for x at first, and x would equal to 2. So let's try it. Okay. So I want you to try it my way. All right. So do you have a piece of paper and like a pencil?
Yeah, I do.
All right, great. So try multiplying the first equation all by negative 3.
Multiply what? By all negative 3.
Just distribute a negative 3 to all of the terms. And then tell me what you get. Do you know what you get after distributing negative 3 to all of them?
I distribute the first equation, so I got 21x negative 3x.
21x and negative 3 what?
Yeah, 3y.
Y. And then what do you get?
Positive 57.
Right. See, that's good, right? So, and then you just solve it as it is. So using, let's look here. So what's negative 2x plus 21x? Or you could think of it as 21.
Positive 19.
Yeah. 19 what?
X.
Okay. And then the next one, what do you do?
You got 0.
And then the final side?
You get 38.
Okay, great. What do you want to do to isolate x by itself?
You would subtract 10 and 38. But
Sorry, this is a 0.
38.
Pretend there's nothing here. So what would you do? 19x equals 38. and you want x by itself.
Or you divide
By,
19. But
Right.
why did you cut the 10?
I'm sorry, that's a 0. I think it's like my handwriting.
Ah, okay.
It was plus 0. So you could just like disregard that. So it'll be 19x equals to 38. And you said divide by 19, right?
Mm-hmm.
And you would get,
2.
great. Okay, so now we have our x value. So what do we do now? How do we get y?
You take one of the equations and solve.
Which equation do you want to use?
Second.
Second. So we have 2, instead of x, we plug in the 2 here. Parentheses, so we know we have to multiply. Plus 3y equals to negative 19. So what do we do?
You got negative 4.
Right? And then just bring down everything else.
Yeah.
Nice. So negative 4 plus 3y equals to 19. Okay, what do you do now?
You add 4 to 19.
Okay, so what's your new thing? Sorry, this is negative 19. So same thing, plus 4. Negative.
Okay. Negative 30. 23.
Negative, okay, negative 19 plus 4, like you said before.
Okay. Negative 15.
Okay, and then what do you do next to get y?
You divide.
And then you get,
And negative 5.
look, you found both. Okay.
Isn't this like a little harder than the other one? Other method.
It's like, to be honest, I prefer, it just depends for each situation. Like, let me show you. Hold on.
Sometimes teachers would say to like find your coordinate points using elimination or substitution, but it all depends on the question. So like knowing both, it would be like helpful, I guess.
It's like in the question, they tell you specifically which one to use for that certain question. It depends. Sometimes they don't, sometimes they do. But for this one, I would use this one if they already give you the y value here. Because after that, all you have to do is just plug it in. So technically, there's a little bit of both here. Like you see in these equations, they don't have y equals to blah, 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 or x equals to blah, blah, blah. You just have to figure it out. So you should know both because they're going to ask you for both.
If they don't ask you either for substitution or elimination, you can just choose one of the methods.
Mhm.
Ultimately, substitution is easier, but
Elimination.
elimination is possible.
We're out of time for today, but we will definitely go over this next class because I feel like we're not like too solid with it. But now that we have like a base, so you know the idea of what to do, the next class it should be easier to get through.